In this video, we're going to find another way to solve systems of equations rather than using substitution or graphing. We're going to use the addition method, sometimes known as the elimination method. Notice how the two equations that we're given are both in standard form and we don't have an x equals or y equals. If we were to add straight down in our two equations, the y's would cancel each other out. They'd be eliminated, and we would have 5x is equal to 15, and dividing each side by 5 we'd have x equals 3. Notice how easy that was. We need to find a y value to go along with this x value, so we're going to substitute that into one of the two original equations. I choose the top one, and that will become 2 times 3 plus y is equal to 7. That's 6 plus y is equal to 7. And subtracting 6 on each side, we get y equals 1. So the solution to this system is 3, 1 very easily, and that can be checked if we wish by substituting into the original system. Let's move to the next system. And again, we have two equations lined up and in such a way that we can just add down and the 5x's cancel each other out. So adding down, we have 7y equals 26, and ouch, we don't like that fraction we're about to create after we divide by 7, but oh well, life goes on, we're going to have to use it. Y is going to equal 26 sevenths. Now we need to find the x value that goes with it, and I suggest we substitute back into the top of our two equations. And I choose the top one because there's a positive 5x in front instead of the negative 5x, and we're solving for x and we'd like a positive coefficient. So here we go. 5x plus 4 times the 26 sevenths that we're going to substitute in equals 17. And apparently we're just going to have to play around with these fractions here. Okay, let's see. Let me continue on here. We're going to have 5x plus, that becomes 104 over 7 equals 17. Now, I don't know about you, but I don't like these fractions, so I'm going to clear the fractions by multiplying through on each side of the equation by 7. On the left, that's going to give us 35x plus, the 7's will cancel here, leaving us 104, equals, okay, 17 times 7, that's 49, carry our 4, 7 plus 4 is 11, equals 119. We're trying to solve for x, so we're going to subtract 104 on each side of our equation, and that will leave us 35x equals 15. We'll divide each side by 35. And we notice on the right here that the 15 and 35 each end in 5. So I'm going to divide that fraction by 5 over 5 in order to reduce it to get x equals 3 sevenths. And I'm out of space there. So our solution to this problem is the 3 sevenths we have, comma, the 26 sevenths that we found up above for y.